Please welcome to the podium Anthony Buonicore.
Anyway, I'm going to talk with you over the next half hour, 45 minutes, about something that's not in the ENFOS platform, but it's an analytical tool that is being evaluated to be superimposed on data that's in the ENFOS tool. And we wanted to share it with you and kind of get your feedback. And hopefully over the next day or so, or later, you can give us some of your feedback if it makes sense to you. Now, I'm going to begin with this. This is the issue of vapor intrusion. And I'm not sure how many of you are familiar with it, but for those of you that are not, okay, what vapor intrusion is fundamentally is if I have contaminated soil and groundwater, and I have volatile vapors that are inside that, let's say, contaminated groundwater, they can volatilize off, migrate through the soil, and ultimately go into a structure, perhaps a residential property or what have you. And it's a relatively new phenomenon. We only really got a chance to be introduced to vapor intrusion about 10 years ago. And we are starting to get our hands on it literally over the last 4 or 5 years. So it's a relatively new thing. But it is something that is presenting a lot of risk. And what I wanted to do is kind of go through the good news, bad news story, with the bad news being there is risk associated with vapor intrusion, which I'll get into in a minute. But there is good news in that we've developed an ASTM standard, and I'll talk about what ASTM is a little bit later. But it has a methodology in it that can be used to help manage the risk. And of course, there's big advantages to that. So let me begin with the whole issue of the risk and the liability. Many of you have had contaminated real estate, I'm sure, in remediation that you're dealing with. And if you were like most of us in this industry and you were dealing with this thing, 5 years ago, 10 years ago, even 4 years ago, you had contaminated groundwater. If it went off-site, as long as somebody wasn't drinking it, you really didn't have much of an issue. I mean, you could deal with it, blah, 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 but it was not what you would call an imminent danger to public health. The fact that now we're aware that these contaminated groundwater streams that are migrating in all sorts of different places, preferably off-site, also have potentially volatile organics, and they can volatilize off and expose human receptors to those vapors. It became a game changer in our industry because the courts finally decided that those vapors represented imminent and substantial endangerment to public health. And that was not true with groundwater, but it was true with the vapors. And as a result, as you might imagine, there have been literally dozens upon dozens of toxic tort class action lawsuits. And the actions are filed under a whole bunch of different rationales, more often than not the RCRA citizen suit provision. So if I'm exposed to, I'm a property owner and I'm exposed to a vapor, benzene from petroleum contamination or perchloroethylene or one of those lovely chlorinateds, and it's presenting an imminent danger to my health, I can sue. There's also provisions to sue under CERCLA or Superfund, which I'm sure most of you are familiar with. And then there's traditional common law claims like negligence, nuisance, trespass. That groundwater plume coming onto my property is basically a trespass. The suits were filed, and I'll show you a couple of them in a little while, but the point I want to make is that as you look at all of the suits that are out there, there's a couple of things that really stand out. They're about roughly 1/3, 2/3 petroleum contamination, chlorinated solvents. So the universe of the lawsuits is primarily in those two areas. And of course, many of you are familiar with the petroleum contamination side, and certainly I'm sure many of you in the chemical industry are aware of the chlorinated solvent side. The other thing is these plumes migrated off-site, and they impacted residential properties. And that's what caused the issue. The big thing here, residential properties. And I've indicated here in the next two slides, you have copies of these in your little flash drive, so you can have your attorneys look at it if you're interested. But every one of these are just the highly publicized cases that involved vapor intrusion, all of them either chlorinateds or petroleum. And I did try to highlight here the issue of whether you're dealing with chlorinated solvents like TCE, PCE, those types of things, or petroleum contamination. You know, and generally you're dealing with benzene, toluene, xylene, what have you. And I put the date, and you can see it's all over the country, and I had 2 slides of them, and I stopped in 2010. There's about another dozen or so in 2011. So as you can see, it's becoming a very, very attractive area for liability and lawsuits. And you can notice names like this. You ever watch the TV commercials? Whites and Luxembourg? You know, they're the ones that put together class action lawsuits. And here, this is a great case because DuPont sold the site. They were out of it, but of course they were chlorinated. It impacted the residents here, and these guys are out there and rolling up, literally going out on foot and rolling all the people to get a nice big class action lawsuit, which was then filed in 2010. Anyway, it is a risk. There certainly is risk associated with it. But on the other hand, there's also some good news in that there are now ways to manage the risk. And one of the ways and the methodologies that we're looking at is based on this ASTM E 2600-10 standard. For those of you not familiar with ASTM, it's the American standard setting body. They have standards for everything. I mean, the glue under this carpet, the size of cribs and all that stuff. And they have a section that deals with environmental standards. And in 2006, the industry got together and said, look, we got to come up with some way of being able to evaluate the risk associated with vapors that are migrating. And of course, it's a consensus-based standard, which means that you have thousands of people that are able to comment, and every time any one of them says, I disagree, you have to specifically deal with his comment or her comment. So it takes time. As you can see, it took 4 years to actually develop the standard. But the standard's out there. It's specifically oriented towards screening for vapor migration. And there are things in it that you will see in a little while that can be used to help you manage the risk. Now, the standard itself was developed primarily for that top bullet there, the due diligence in phase 1s associated with property acquisition. If you are now buying property, I'll almost guarantee you your environmental consultants, when they do phase 1s, will somehow consider vapor migration because it's required under CERCLA. It's included in the definition of a release. It's also required under all appropriate inquiry. So the due diligence phase 1s that are done today traditionally never considered vapors, but today they're going to look at vapor migration to see if some of the vapors, where are they going, can they impact the property, what have you. It's also been used in 2 other areas, risk assessment and screening, usually associated with off-site contamination or contamination that's migrated off-site, and then with contaminated property remediation. In the past, many remediated properties never considered the vapor pathway for a human receptor. Today, they do. In fact, EPA, in its hazard ranking system, which as many of you know if you're involved in CERCLA or Superfund, you're aware that the hazard ranking system is a way that EPA goes about ranking sites to see if they should be on the Superfund list. Never considered vapor pathway. EPA is now in the process of evaluating, including the vapor pathway in it. So more and more, if you're dealing in 37 states today, this vapor pathway now has to be considered. Whereas in the past, it wasn't. Now, what's in that standard are a couple of things that I'm going to kind of just extract from it, and I want to get some terms out first, and then show you quickly how those terms are used or how they're used in the risk management process. The first are what are the chemicals of concern? And generally, you may think they're the volatile organics, the volatile organic compounds. You call them VOCs. Your consultants probably call them VOCs. It also can include semi-volatiles like naphthalene. It can include things like volatile inorganics. Mercury, which was one of the best litigation cases I've ever seen, where it was in. Anybody here from New Jersey? You heard about Kitty College? I mean, if you're going to build a daycare center, where would you put a daycare center? Would you put it on an old thermometer manufacturing site, which has mercury in the thermometer? God almighty. That's where they put it. That caused a concern. Anyway, there are chemicals of concern. I have a slide, a little bit more detail in a minute. There's a term area of concern, which has to do a lot with how far plumes migrate. And years of work was done on evaluating plume migration, how long the plumes are, how wide. We had on our task group over 300 professionals, and we had many, many organizations. In addition to EPA on our task group, we had the American Petroleum Institute on our task group. We had, for those of you that are in the petrochemical area, we had Paul Johnson and Robbie Ettinger, who developed the Johnson-Ettinger model for vapor migration through soil for Shell back in 1991. And we all, with the halogenated solvents, everybody was there on both sides, because you have to have an ASTM, all the stakeholders around the table, you know, all with their own agendas to try to come to some sort of consensus. We also did a lot of work, and this was primarily from the experience of the approximately 200 professionals, usually the consultants, who are working on all the vapor intrusion sites in this country. And here the interest we had was how far do vapors go, how do they move, things of that nature. So we had a lot of people with a lot of good expertise helping us with these parameters to identify an area of concern for this thing called a critical distance. Now let me just show you a little bit more on each of these, because they are important when we talk about the methodology. These are the typical chemicals of concern, although this is off a little bit, as you can see. This should be raised a bit. But those are the most common, for obviously petroleum, which I'm sure you're all aware of, and chlorinateds. I will add that states now, I think there's now 27 states that have things called screening levels. And I put these up. These happen to be New Jersey's screening levels. They're called RSLs, risk screening levels. Those are levels of contamination that if you're below that level, no problem with vapor, you know, migrating into a building and causing a health risk. If you're above that level, you may have a potential health risk issue. And I put these here for one reason. These are many, many, many times lower than the drinking water standards. So that's new. You know, normally we were always worried about the drinking water standards in, for example, groundwater. But now you got this whole new set of data. And of course, those numbers, the states have different numbers. They may be similar to this. They may not be. It all depends on the state that you're in, which of course complicates the issue. But in any event, the idea is if you are above one of these screening levels, potentially the vapors can migrate through the soil and go into a building and create a public health issue. It has to be evaluated. Now, the area of concern was kind of interesting, but it's important in the methodology in that we, as I said before, collected data on plume widths and plume lengths on literally thousands upon thousands of chlorinated plumes, petroleum hydrocarbon plumes. We had all the API's data, which they had given to us. It was all evaluated statistically. What we were trying to do is come up with, you know, if we want to have an area of concern, it has to consider how long the plume is, you know, let's say following groundwater, how long is it, how wide is it, and then assuming that the vapors on the edge of the plume going in this direction continued, you know, volatilized off, how far could they go? Well, you have to analyze things statistically, and the experts on our task group with EPA's prodding decided that the 90th percentile plume length was the most appropriate plume length to use. And I think the 90th percentile plume length was a couple of hundred feet less than that 1,760 feet that you see up there. What that means is that 90% of the plumes were less than that number. Okay, but they still were 10% larger. Now you can't, you know, you don't want to design a screening methodology that handles everything absolutely, because we have Superfund plumes that are miles long, and that's not the way the world works. You deal with things statistically. Many of us wanted the 50th percentile plume length. EPA really pushed for the 90th percentile plume length. And I've learned one thing: when EPA pushes, most people kind of step back and say, okay. But as you can see, in the 90th percentile plume length, and considering how far vapors migrate, and I'll come to that, back to that in a minute, the lengths we're looking at for the area of concern on chlorinated COC plumes, non-petroleum hydrocarbon plumes, were 1,760 feet in the direction of groundwater flow, and 530 feet wide. Similarly, for petroleum hydrocarbon plumes, 528 feet and 130 feet wide. So those of you that do have gas stations that have contamination, certainly it would be interesting to see what your lengths of your plume and the widths of your plume were, but I would be willing to bet quite a bit that the odds are you're going to be within that area that we looked at there, the 528 feet and 130 feet wide. We also had, remember, in this slide over here, in that back slide, can I go back? Yeah, I mentioned that reflects vapor migration distance. In other words, how far does vapor travel in the soil? We call that in our standard the critical distance. And just for the record, because it is used a little bit later in the methodology, for chlorinateds, for non-petroleum hydrocarbon COCs, the distance, statistically the best distance for the vapor, how far it could migrate conservatively, is not more than 100 feet. So everybody felt pretty good with the 100 feet number. For petroleum contamination, there were two sets of numbers. It depends on whether you had just dissolved contamination in the groundwater or if you had floating product on it. So you had gasoline floating on top of the water table. In that case, if it is floating on top of the water table, the distance was still 100 feet, ironically, same as for COCs. However, if you're just dealing with dissolved contamination in groundwater, it was 30 feet. And the reason why petroleum contamination was a lot less is because there's a lot more biodegradation of this stuff in the soil compared to chlorinateds, which have a tendency of being very pervasive. And the bugs don't like them. Okay, so what's the methodology? Well, fundamentally, it was a four-step process for establishing the methodology. You got to collect data. You got to evaluate this thing called the plume migration impact zone, which you'll see in a minute. Then, of course, you want to be able to prioritize, because the goal is to be able to prioritize properties so that you spend your money most cost-effectively on the remediation where it's going to save you in the long run. And then the issue, I'll say a few words on things change, and so therefore there's a need for this not to just be a one-time affair, but something that is done on some basis, whether it's 1 year, 2 years, whatever, remains to be seen. So let's deal first with the data collection aspect. A lot of data gets collected. A lot of this data is in the system. Some of it still has to be added to the ENFOS system, but you can see here there's data on the contaminated groundwater plume, which way is groundwater going, what the concentrations are, the remediation status, if you have a known plume length and width, is the plume still moving, is it stationary or what? The surrounding area is critical. You're aware, like ENFOS now has sensitive receptors in there. Also, the addition would have to be made for residential development, because this becomes a key, how close those residences are. There's also other sites in the area, because obviously most of you are familiar if you're involved in Superfund in any way. If you can get some other potentially responsible party to help you in the deal or fuzzy up the deal, it certainly makes sense to do that. And then there are, collecting those risk screening levels. Again, it depends on the state that you're in. And then certainly, and last but not least, and this is very iffy right now, the soil characteristics. There are certain soil characteristics like clay soil, silty soil, where the vapors, it kind of impedes vapor migration. And there are some things that a consultant can do that if they know this, it can help them reevaluate the area of concern, but I don't want to get into that now. Then after data collection, you've got to worry about trying to identify what this plume migration impact zone is. And fundamentally, it's the zone that considers the groundwater plume, where it's going, plus the vapor, how far those vapors are going to go. And it's identified in two ways for both a known release and a potential release, and I'll explain what those are in a minute. The known release is where you've got a release on a site, and you have a pretty good feel for the size of the plume. It's been well delineated. You know what the risk screening levels for the state are. You're above those risk screening levels. Okay, what you're going to do in essence, or the idea behind the analytic tool, is that it will establish a buffer zone around the known groundwater plume and see if within that buffer zone there's residential property. So if you look at it, it looks something like that. There's my groundwater plume. It's migrated off-site. And you can see here, here's my vapor migration zone. Those are the numbers we talked about before. Oh, lo and behold, there's a residential property that could be impacted by that vapor migration zone here. Okay, that becomes an issue on the site. Obviously, from a priority standpoint, it'd be something that would be high priority to be able to deal with, because those vapors could be impacting or going into that residential property. Then you have the case where there's a potential release, or as I define, two things. A release where you have a release at your gas station site or your plant, but you haven't totally delineated the plume. So you don't really know how big it is. Okay? Or you have a site where there's a potential, I'm concerned about a potential release from this particular area, maybe where there's a large tank. And if there's a heavy flood or heavy rainfall, some of this soil might migrate, and be released into the off-site area. In that case, and again, using the numbers that we talked about before, the plume widths and lengths that I referred to before, you're looking at something like this, where I have a source, and maybe the actual plume, based on the data that's input into ENFOS, is like this big, right in here. But you don't know. It's still migrating. You don't know where it's going to go. You don't know how long it's going to be. Well, using the 90th percentile numbers, you can set up a box. And this is simplistically a way to look at it with those dimensions that we talked about before. And if you look at that box and you look at those dimensions, you can see if it potentially can exceed the property boundary. If it can go beyond the property boundary, lo and behold, if there's a residential property there, uh-oh, I have a potential risk. So conceptually, the model looks fundamentally for the presence of residential property or sensitive receptors, daycare, wetlands, things of that nature, that can be impacted by the plume migration zone. Now, you then have to prioritize it. And the concept that we have that we're looking at for incorporation into ENFOS is like a red, yellow, green. Red being the highest priority to consider. Yellow, you can worry about a little bit later, and the green are low on the priority list. Number one, clearly, is if you are dealing with any kind of contamination with volatiles, petroleum or chlorinateds or what have you, that is going under residential property, that's highest priority to clean up, especially with the issues of toxic tort litigation that exists today. The second is where you have vapor that's coming off the groundwater. In other words, the plume isn't under the residential property, but the vapor migration could actually reach a structure, a residential structure, and cause an issue. And you'll notice, too, that in each of these cases, you may be the only PRP and you're out of luck, but if there are some other PRPs nearby, that's always a big advantage for you, especially if this does come into litigation. The third, of course, is if the groundwater plume is migrating, and you're not sure where, but it seems to be heading towards a residential area. We know what distances, at least at the 90th percentile, how far it can go, how wide it is. I got a problem. It potentially can reach it. Those are the kind of like the 1, 2, and 3 priorities. They're all red, but there's obviously the highest priority is the first, and the lowest of the reds is the number 3. Then, of course, you have this issue here where there's a potential release, or maybe you have a known area, a known plume based on data that's going into the ENFOS system from your consultants. And it may reach or may not reach a residential property. It's not certainly as serious as being within the zone, which is what 1, 2, and 3 are. So that would be classified as a yellow. And then, of course, everything else is classified as a green. So it is a red, yellow, green type of analytical tool in looking at portfolios and trying to prioritize them. One of the things certainly we would be interested in is if you talk to the engineers that you have who are certainly going to be aware of vapor and how they would view the vapor risk associated with plumes, contaminated plumes that you may have in your own facilities and plants. The other thing, too, is, as I alluded to way at the beginning, is it can't be a one-time only. A lot of things change. You know, plumes do migrate. You get new concentrations in those plumes. Even the state risk screening levels change. For example, many of the levels have changed over the last 6 months because EPA came out with a new health level for trichloroethylene. And that impacted risk assessments, states did, so they had to come up with new RSL for trichloroethylene. But there have been other changes. You know, there's changes in the nearby area, whether they be residential, sensitive receptors. There's changes in the status of remediation and contamination concentration, all that stuff. And the idea is conceptually that one would go in at some frequency, you know, to be decided, to reevaluate and see if things and the priorities stay the same based on what the new situation or the new scenario is. So if you look overall and you look at the benefits, there are ways to deal with the risk. Certainly, properties needing cleanup can be prioritized. You'd be able to do this in a way where you could certainly do it cost effectively, in that you want to spend the limited amount of dollars that are available to you, like in most places, where it's going to mean the most. And the idea here is you want to reduce that liability risk of those vapors impacting residential properties and causing some sort of a toxic tort lawsuit. And again, since we are living in a time where monies are very limited, you want to spend them the most where it's going to mean the most. And this is certainly one way of doing it. So again, it's a good news and a bad news situation. The bad news clearly is that this new thing called vapor intrusion does represent a significant potential risk. There are a significant amount of toxic tort suits already underway, and that just keeps going up because lawyers now are getting educated on this. And as they get educated, obviously you know what the end result can be. But on the other hand, there is some good news in that it is a risk that can be managed conservatively, and it can be managed using the screening numbers, the methodology that's built into the ASTM E 2600-10 vapor migration screening standard. And if you do that, you certainly can use it as a tool to look at a portfolio, find out where the greatest risk is, and focus the limited dollars that are available on where that greatest risk is.